We'll now look at trig substitution. So the idea here is I'm going to start with substitutions for a squared minus x squared. So if I think about a triangle with an angle theta, I'm going to label the opposite side x, the hypotenuse a, and then this side will be the square root of a squared minus x squared. So I want to pick a value for x. So in this case, I'm going to let a be equal to x sine theta. And we can see that sine theta will be opposite over adjacent, which is x over a, times this a out front, which is just x. So this substitution does work. And if I make this substitution, a squared minus x squared is then equal to a squared minus a sine theta squared, which is the same thing as a squared minus a squared sine squared theta. I can then factor out an a squared to get a squared times 1 minus sine squared theta, which then becomes a squared cosine squared theta. So when I make this substitution for x, I'm going to get an a squared cosine squared theta in my integral. So for example, I want to find the area of a circle with radius a. We're going to do this using calculus. So I'm only going to consider a fourth of the circle, particular between 0 and a. Since this is a quarter of the circle, I'm going to have to multiply by 4, going between 0 and a. And the formula for the circle will be a squared minus x squared dx. So I'm going to let x be equal to a sine theta, which means dx is going to be equal to a cosine theta d theta. So this is 4 times the integral of, like I said in my last slide, the a squared minus x squared is going to become a squared cosine squared theta. And then dx is another a cosine theta d theta. I'm also going to want to change my bounds. If x is equal to 0, then theta would need to also be equal to 0, since sine of 0 is 0. If x is equal to a, then I have that sine of theta must be equal to 1, which gives me pi over 2. Reducing this integral, this becomes a squared cosine squared theta d theta, which is 4a squared times the integral between 0 and pi over 2 of cosine squared theta d theta. So 4a squared times, and we can use the reduction formula for cosine here, and you can verify that what it should be is 1/2 times cosine theta sine theta plus theta between 0 and pi over 2. So when we evaluate this, we get pi over 4, which you can double check again. So when we multiply this out, pi a squared, which is the formula for the area of a circle with radius a. Let's try another one. In this case, I'm going to let x be equal to, so we need a, sorry, this should not be an 8, let's make that a 9. A, which is going to be 3 sine theta, which makes dx equal to 3 cosine theta. So the numerator here is dx, so that's going to turn into a 3 cosine theta d theta. The denominator is a 9 minus x squared. So, as I've said before, when I substitute this in, this is going to become an a squared cosine squared theta to the 1/2 power. Reducing this, I get 3 cosine theta over 3 cosine theta d theta, which is just equal to the integral of d theta, which is theta plus c. However, I do need to move back in terms of x. So I'm going to think about my triangle. Here's my angle theta. This is x, a, and the square root of a squared minus x squared. Well, I know that a in this case is 3. And I know that we let x be equal to 3 sine theta. We can divide by 3 and then take the inverse sine of both sides to get that sine inverse of x over 3 is equal to theta. So my final answer is actually sine inverse x over 3 plus c.